Hello, my name is Kristen Kroll, Product Specialist for igus in the Linear Systems Group. We are very excited to introduce the D3 DC motor controller. The D3 DC motor controller can be used to drive a belt-driven table, screw-driven table, gear rack table. These are the necessary components to assemble this test stand. Today I'm going to be showing you how easily they go together, and I look forward to showing that to you. This is the new D3 DC motor controller, and we're going to show how all the pieces go together to run a ZLW 0630 from igus. igus motor flange. It's modular, the pieces fit together depending on which motor in slide you choose. Coupling. This particular coupling comes with one end square to fit on the ZLW belt-driven table and one end round to fit on the motor. This is an igus DC motor. The slide table comes with these clamp feet to mount it to a table. The fasteners come in the motor kit. All you need to purchase yourself: Allen keys, DC motor supply, some wire, two pieces, and they're already on the motor here, connected with a flat pin. And then you'll just need to prepare the wires to insert them into the controller. You can use a wire stripper. Another thing you can do is use your fingernail to cut it, pull, twist the wire, and it's ready to insert into the D3 DC motor controller. That's all you need. We will now start the assembly of the D3 DC test stand. I have in my hand a ZLW 0630 belt-driven table. It has a square drive shaft, and we're going to put the motor flange on. The motor flange comes in two pieces. This end slides right onto the ZLW 0630. Just lightly press. The motor kits from igus come with all the necessary fasteners. Make sure that the motor flange is nice and secure. After I put this piece of the motor flange on the slide table, I'm going to put the other piece onto the DC motor. Make sure I'm putting it on the right side. Put the screws in and kind of across from each other, and make sure that the motor is secured to the motor flange. Now I've got the motor flange connected to the motor and the ZLW. What I'm going to do next is put the coupling on, square side, onto the ZLW. Just simply slides on, and then we'll put the motor side on. Make sure that it's spaced, the coupling's right in between. You don't want it hitting the screws, of course. Then once you have the pieces put together, there's two more fasteners. And again, make sure all your fasteners are good and tight. So now we're going to make sure that the fastener on the coupling is set to the required torque spec of 2 Newton meters. I've set the torque wrench to 2 Newton meters. Start tightening it. We have this fastener set to 2 Newton meters of torque. Please be sure that you also fasten the other to 2 Newton meters. So now we're going to take the assembled ZLW 0630 that has the DC motor on it, coupling, and the motor flange, and we're going to assemble it to the test stand. I'm just going to put the wires back here so they're not in my way. For our purposes today, it'll be easier to just screw these in just a bit so that I can still get the slide table on there. Put the top ones in. They just slide right into the slot here on the side of the extrusion. So that's one of the benefits of the tables. It's very easy to fasten down, and you want to make sure that you get these fasteners in there all the way, otherwise the top of the carriage could hit it. And now we're going to take the D3 motor controller and there's pre-drilled holes for this as well. The controller is now on. Our ZLW0630 is now on. The next thing we need to do is start connecting the D3 controller. Now that we have our linear actuator and connected to the DC motor via the motor flange and coupling, we have our D3 DC motor controller secure on the test stand. We want to grab our motor data sheet, and it shows how to insert the wires into the controller. So I'm going to start with connecting the DC motor. The most important thing is to make sure you put the plus wire into the X1.1 and the negative wire into the X1.2. And then after, we'll put the power supply into X2.1 and X2.2. So here's X1 and X2. The positive goes into the first. Put in a small screwdriver. You can also use a plier, might make it a little bit easier. Take the negative wire, spin this quickly with my fingers, push in the spot where you connect the wire. Good. So we grab our power supply. The wires are already prepared. This wire is the 24 volt power supply, the positive, and this is the ground wire. In this case, we look at our wiring diagram and we put the 24 volt power supply into X2.1 and push down. Just insert the wire, then just twist it, make sure the wire is nice and tight. So now we have the motor wired and the power supply. At this point, it is actually usable once you put it into tip mode, but we're going to also wire in the switch or the joystick, and you can use any type of switch that you would like. So to connect the joystick, we just take the wires, you make sure you put the right and the right, the left and the left, so on, and then you just, again, push in. Insert the wire. Remember, we had prepared these earlier, and we're done. And we're ready to use the D3 controller. There's some basic settings on the D3 DC motor controller. There's the tip mode and the start to end mode. This is tip mode. And then if you just flip the switch, it goes to the start to end mode. And I'll put it back to tip mode. And I'll demonstrate that for you. You can move the carriage back and forth directly using the S1 and S2 buttons on the D3 DC motor controller, or you can use a joystick or any type of switch. And if I put the dip switch 1 up, now it will go to start to end mode. And I can directly control the speed on the D3 controller. The D3 DC motor controller can be used with or without a sensor. In my hand I've got an inductive, normally closed PNP sensor. You would just connect it to the belt-driven table with a bracket, and it would just sit probably towards the end to detect the carriage and stop the motion. If you're not using a sensor, you'll want to set the D3 controller to the block mode, and you'll put the dip switch 2 up. If you're using a sensor, you'd put the dip switch 2 down.